Yeah, so tomorrow, raise your hand if you are not testing tomorrow. If you are not testing tomorrow. So we've got 4 of you, 5 of you, okay, 6 of you, okay. Just gonna do it again just for fun. Yeah.
I mean, I could not get better than that. I got 21 on the ACT.
I would say that I would expect you to be higher than 21. Yep. But now you've had pre-calc, so who knows now, right? But at the end of the day, the ACT really is about one thing, and that's about getting you into the school you want to go to, and then hopefully providing you in a financial spot that works for you. And so if you could check both those boxes, then you know that's fine. And so then you just look past the ACT after that. Okay. So here we have this, and so what's the big idea? Well, tomorrow, it's really going to be a day for you guys to work and ask questions. You guys are the fortunate hours. So, because the juniors are all testing, I'm not going to cover a new lesson tomorrow. And you guys will be coming back from just taking the ACT, right? It's not like we're going to go into a whole new lesson. We're going to give you guys a break. You guys can ask questions and get to work, which is a good deal, right? Okay. So this time of year when we have these disruptions, we always slow down, we accommodate, okay? So just know that that's taking place. Some people have suggested after taking the ACT, they may need to visit the hospital, that they'll be that fractured from it. I ask, how would the greatest generation who fought World War II respond to those things? I mean, it's not the hardest thing in the world. We're going to have to show up and take that ACT, is it? It's not going to be too bad. I don't know. It's going to be a little while. But anyway, on Wednesday, we are going to do something called de Moivre's theorem. If you don't know how to do today's lesson, you won't know how to do Wednesday or Thursday. So I would say that in my mind, I would say Thursday's lesson is the hardest lesson you have left for the rest of the year. Once you make it through Wednesday and Thursday, it's all downhill from there. That's my point of view. Some people may disagree with me, but that's my opinion. In order to be successful on Wednesday and Thursday, you absolutely have to know how to do this. This is brand new. You've never seen it before, but it is not complicated. It is not complicated. You can make it complicated. You can find a way to confuse yourself, but it is not complicated, trust me. You ready? Okay. If I have a number such as 3 and I plot it on a number line, I just find 0 and I move 3 points over and I say that's 3, right? Well, what about other numbers? What about like 3 plus 2i? That's what we call a complex number because it has both a real part and imaginary part. That makes up what we call the complex number system. Well, we see that it does go over 3 units. But what do we do about this whole I piece? Like, where does that fall? And so as they develop what we refer to as that complex number system, they developed a real axis, which is what you are used to seeing, the real number line. And then they also have what they call the imaginary axis. This is not the x and y axis, though it looks about the same. You have a real axis and you have an imaginary axis. Together, those make up what we call the complex plane. So while the number 3 goes on a real number line, the number 3 plus 2i goes on the complex plane. It simply just goes over 3 units and up 2 units, and that's it. That's it. So when it says graph z sub 1 is equal to 2 plus 4i, z is the variable used for complex numbers. So it says graph the complex number 2 plus 4i. So we're going to go right 2, and we will go up 4. What do you think? Yes, and you draw a line going from the point to the origin. So it's graphed as a segment. It's graphed as a segment, not simply just a number.
No, I was just going to ask why was that?
We'll see it in a little bit. Z sub 2 is negative 1 minus 5i. So in that situation, I will go back 1 and I'll go down 1, 2, 3, 4, 5. Next, it says to do z1 plus z sub 2. So all I'm going to do is add these two together. 2 and negative 1 make 1. 4i and negative 5i make negative I. So I go over 1 and down 1. That little green segment is the sum of the red one and the blue one. Which may look weird, but that's what we get. You okay with that? The next one says negative z sub I should be negative z sub 1. Sorry about the I that popped up in there. And so all that means I'm going to take this and multiply it by negative 1. I get negative 2 minus 4i. So I'm going to go back 2 and down 4. Can somebody tell me how does negative z sub 1 compare to positive z sub 1? They're just the exact opposite directions, aren't they? That's all it is. But they have the same length, don't they? Yep, just opposite directions.
Why do we use z here?
Z is just the number that, the variable, and you could choose any, but it's the variable is generally reserved for the complex number system. So if you consider x and y are reserved for these real axes of x and y, z is to show that we are trying to work with a complex number that's not your normal xy axis. Okay, and then finally 1/2 z sub 1. So you just take z sub 1 and multiply it by half, you get 1 plus 2i. And so I'm going to go over 1 and up 2. How does 1/2 z sub 1 compare to z sub 1? Yeah. Zizi, how do you feel about these?
I'm really enjoying these. I like these.
It all of a sudden just connected for me. Like about 2 minutes before I asked you, I was like, oh, Ziz and Zizi. I bet she's enjoying this. So good. We'll do what we can. We do have other units where we use the letter T, and maybe Taylor will get excited when we do those. Okay, well, who knows? Will you be able to control the excitement is the bigger question. Okay, so my outrage when I get to the test and I give people a number to plot and they put it in the wrong quadrant. Folks, can we say that that's something we're going to avoid doing? That if you get a positive and positive value, it's going to be in the first. And if you get a positive and negative, it's going to be in the fourth. But yet when I give people a negative and a positive, sometimes they end up in the first, sometimes they end up in the fourth. They should be in the third, shouldn't they? Okay, those are the mistakes we don't want to make. Okay, we can do better than that. We really can. Okay, so this leads us to the next definition, which is the modulus. And the modulus is simply the absolute value of z. Now, how do we find the absolute value of something? Well, so my daughter, she's in 6th grade, and she doesn't love math quite the way that the oldest one does, nor the way that her father does. But she likes math. She does. And if you were going to describe to her what absolute value was, what would you tell her absolute value is? Yeah. The distance from 0. Yeah. And so if you think of 3, the absolute value of 3 is 3 because it's 3 units from 0. And the absolute value of negative 3 is 3 because it's 3 units from 0, right? So we're going to use that same idea. Sometimes we just think about it just makes everything positive. But there's more to the meaning than that, isn't there? So if we were to plot a coordinate called a plus bi, and we were to plot it there, then that means that the absolute value of that would be its distance from the origin, right? Well, how do we find that? Well, we know we went over A units, and we know we went up B units. Pythagorean theorem. You see it? So therefore, the modulus is the square root of A squared plus B squared. And so for a moment there, you're thinking, why are we talking about complex number system when we're in trigonometry? Well, you can see trigonometry is tied to the complex number system in this way, and other ways as well. So when it says to find the modulus of z sub 1 and z sub 2, you say z sub 1, or the absolute value of z sub 1 is equal to the absolute value of 2 plus 4i. Now, when you see this imaginary term here, or this complex number, we don't simply just make everything positive. Rather, what we do is we take the square root of a squared plus b squared. What do you get if you square a? Or what do you get if you square b? 16. You do not include the I in your squaring. Square root of 20, is that simplified?
No.
I have 2 roots of 5. Absolute value of z sub 2 is equal to the absolute value of negative 1 minus 5i. Sir?
So why do we get an I in the 2 plus 1?
Well, if you notice, it says a squared plus b squared for a plus bi. It doesn't say anything about squaring the I. So in this situation, I have the square root of what? 1 plus 25 is the root of 26. Notice how we came up with this definition for the modulus by just talking about its distance from the origin. I mean, we didn't make it up. I mean, we used our knowledge and our truth of mathematics to come up with that. So can you come up with the absolute value of a complex number? So those are our 2 skills so far. We solved equations the other day, but then so far we have graphed them and we have found the modulus. You're now ready to do the next piece, which is our final block of the day, and it is the most important one. We now want to place these into trigonometric form. Trigonometric form. So a complex number is of the form a plus bi, and we want to change that into a different form. What is that different form? Well, suppose you were to plot a plus bi right there. And again, in math, we don't make anything up. We discover the truths that exist. That would be like over a units and up b units. Okay. And we know that this is the absolute value. That would be that length or distance there. Okay. And so what will this allow us to do? Here's something to allow you to do. Okay, Rachel, suppose I asked you to take 1 minus 3i and square it. Would you be able to do that? Yeah, you would just take it multiplied by itself, right? Estimated time on you being able to do that. Okay, so what about this? Estimated time. Really? I'm going to say a year. I'm going to say to multiply that out 2,000 times. I think it's going to take her a year. She's going to have to have a lot of breaks, right? Like her brain be hurting after that. Like some people were complaining about like a 4.5 hour ACT. Like you want to complain about something, complain about that. You're going to be able to do that on Wednesday. We're going to be able to do that in less than 5 minutes. Okay? But the secret to being able to do that is to first put it in what we call trigonometric form. Trigonometric form is extremely useful to be able to carry out ridiculous operations with numbers. Okay, so trigonometry makes us think of a couple things. Makes us think of theta and makes us think of r. Ooh, those are friends we used to talk about, right? So what I have here is I have the expression of a plus bi, and what I would like to get rid of is I don't want a there anymore. I don't want a. I want to replace it with r and theta. So if I point to A, R, and theta, which trig function comes to mind for you? Cosine. Namely, the cosine of theta is equal to A divided by R. Again, look at what I wrote. I need something for A, so I will simply multiply both sides by R. So R cosine of theta is equal to A. So that thing's going to go right in for A. So I found something to replace A with. You might not like it, but I found something to replace it with. Okay, now I'll point to some other ones. I've got to substitute something in for B. So how about B, R, and theta? B, R, and theta. Sine, namely that the sine of theta is equal to your B value divided by your radius. And if I multiply both sides by R, I have R sine of theta is equal to B. So I'm going to take this and drop it in there. Good? If we look at those now, if we substitute those A and B values, we get R cosine of theta plus R sine of theta times I. And the way we customarily write that is we factor out the R. We have R times the quantity, cosine of theta, plus, and we drop the I in front of sine so it doesn't get confused with the theta on the end. R times the cosine of theta plus I sine of theta. This is actually kind of the last piece of information, juniors, that you would need to see on the ACT exam. So this is kind of the tipping point for the last stuff that they would expect that you would be able to see. Okay, an introduction to new complex analysis, which is pretty cool. Now, in order to convert it from A plus BI into this form, we need to know two things. We need to know R, and we need to know theta. Somebody, please give me an equation for R. Square root of A squared plus B squared. Everybody agree? We already know R. It's the same thing as the modulus. Everybody with me there? Okay, then let's determine theta. Theta, I'm going to look at these two values of A and B and theta. Which trig function, A, B, and theta? Tangent. Namely, that tangent of theta is equal to the B value divided by the A value. Right. So as I flip into your notes, Kenny, I'm looking at this sheet right here. This is where I begin to put kind of some of those other unit formulas. So if you're kind of wondering, are you going to get some of this stuff on the test, you're going to be able to reference it all right here, okay? So I think that stuff's sitting right on there, isn't it? Okay, very good. So we're going to do these three examples and call it a day. We have to be able to determine the trigonometric form of these complex numbers. And here we go. So it says write the following in trig form. I need to determine R and theta. R is the square root of A squared plus B squared. What is A squared? 4 plus square root of 8, which reduces to 2 roots of 2. And then I set up tangent of theta is equal to B divided by A. What is B divided by A? So B is just the value in front of I. We do not include the I in the computation. So I just get 1. Everybody agree? All right, so in order to solve for theta, I consider my quadrants. Tangent is positive in which quadrant? First and third. If I inverse one on my calculator, what do I get? 45 degrees. So what are my two angles? 45 degrees and 225 degrees. So which one am I talking about? Am I talking about the 45 or the 225 or neither or both? You're very good. Rachel sees it right away. She sees if you were going to plot this coordinate, 2 plus 2i, in which quadrant would it plot? The first quadrant. So you choose the 45 degree angle. If it was negative 2 minus 2i, then we choose the 225. And here's the last thing. When we work with these, we do not express the answer in degrees. We express the answer in radians. So the radian measurement for 45 degrees is pi over 4. Going to have to remember those. So our answer is 2 roots of 2 because it's r, remember it's r cosine of theta plus I sine of theta. So 2 roots of 2 times the cosine, and your theta value is pi over 4. And then you get I sine of pi over 4. Nope, this is the answer. We've written the answer in trigonometric form. I know it looks kind of gross, but it is what it is. Okay? All right, 2 more. Negative 3 plus 3i roots of 3. How do I find r? What is negative 3 squared? 9 plus, and then if you take 3 roots of 3 times 3 roots of 3, or 3 roots of 3 squared, what's 3 times 3? 9. What's the root of 3 times the root of 3? 3. And 9 times 3 is? 27. 9 plus 27? 36. Square root of 36. So your radius is 6. And then we have the tangent of theta is equal to the b value divided by the a value. 3 roots of 3 over negative 3. Negative root of 3. Where is tangent negative? Second and fourth. I was just typing the root of 3 so I get 60. Am I talking about the second quadrant or the fourth quadrant? Which one? Second, because you go back and then up. See? Back, then up. If you were going to plot this. If it was positive, negative, then you go over and down. See the difference? So if this is 60, that's 120 degrees. And what's 120 in radians? 2 pi over 3. So our trigonometric form is, I'll write it in red, 6 times the cosine of 2 pi over 3 plus I sine of 2 pi over 3. Okay. The last one. Yes. So A is 0 and B is negative 2. So I have R is equal to the square root of 0 squared plus, what's negative 2 squared? 4. And 0 plus 4 is 4. Square root of 4 is 2. So my R value is 2. Tangent of theta is equal to, what is B divided by A? Undefined. Where is tangent undefined? So Rachel went to the tangent is slope, and she said a line has undefined slope when it's a vertical line. And vertical line, that would be 90 and 270. So are we talking about 90 degrees or 270 degrees there? 270, because if you're plotting negative 2, I'd be down on the y-axis. So 270 is what as radian? Good, 3 pi over 2. So we have R, which is 2, times the cosine of 3 pi over 2, plus I sine of 3 pi over 2. Question?
So, okay, so this is why 270 is
Yeah.
Because of it being.
Yep.
Okay, got it.
Now, I just want to show you guys a way to save a little bit of time, okay? And if this works for you, great. If not, I get it. But I never would have done the problem that way, okay? Here's how I did the problem. And see if this connects for you, okay? I would just visualize it, and I would plot negative 2i. Everybody agree it plots right there? So the r value is its distance from the center. How far is it from the center? 2. That wasn't very hard, was it? And then I know that angle. What's that angle?
270.
270, 3 pi over 2. I didn't set any of that up. Get my point? So if you can visualize it, great. Okay. Last thing here, just so you understand what the heck you're doing. What is the cosine of 3 pi over 2? What's the x value down here?
0.
Everybody agree it's 0? So we'll make that 0. What's the sine of 3 pi over 2? The y value is negative 1, right? So it would be, wouldn't it be plus, it would be minus then, right? Minus 1 times I, or minus I. So if you plug in, so you get 0 for this, and you get negative 1 for this. So 2 times 0 is 0, and 2 times negative I is negative 2i. That's what I started with, right?
Yeah.
If you were to determine the terminal points for all of these and multiply it back through, you should come up with exactly what you came up with in the beginning. You're just converting from one form to another. Not too bad? New, but that's not super crazy, is it? I mean, we can do that. Great. Take out your homework so I can set you up for success there. So my apologies, but again, when I put your homework together, I made some mistakes. And you can see that this one right here, this is where your assignment starts. It says it's page, it's you know, it's kind of your third assignment, and it says trigonometric form of complex numbers. Is everybody there? Now, look at the first problem. It says graph and find the modulus. That does not mean you have to put it in trig form. Simply graph it and determine the absolute value. That's it. Bottom parts, just graph. Now, when you then flip a couple pages, you come to this page right here. It also says trigonometric form of complex numbers on the top. Okay? And that's the one where you want to put it into trigonometric form. So the r cosine of theta plus I sine of theta. That's what you want to do here. Okay? So you guys are going to get time to work on this tomorrow. First and second hour are not. I would encourage you to try to do what you can do tonight. But make sure you stay on top of this unit, especially if you're behind from the equation solving. Again, this is a tough test. This is not a test that goes super well. So stay on top of it, do your best. Stop.